Hi everyone, let me start our talk. Our talk is Koalas, interoperability between Koalas and Apache Spark. We will introduce how PySpark users effectively work with Koalas. I'm Takia, a software engineer at Databricks. I'm an Apache Spark committer and PMC member. My focus is on Spark SQL internal and PySpark, and now I'm mainly working on Koalas project. And Hejun is also a software engineer at Databricks and a Koalas contributor. He will play a demo later to show you examples related to topics I present here. In this talk, I'll introduce Koalas and also pandas and PySpark. Then I'll show some important APIs to work with PySpark easily and efficiently, starting with conversions from and to PySpark DataFrame. Next, I'll show some I/O APIs or Spark accessor. After we roughly see those APIs, we will see the demo by Hejun. Firstly, let's look over Koalas, pandas, and PySpark. What is Koalas? Koalas was announced on April 24th at the previous Spark AI Summit. It's a pure Python library and provides a drop-in replacement for pandas, enabling efficient scaling out to hundreds of worker nodes for everyday data science and machine learning. It's trying to unify the two ecosystems with a familiar API and to help to make a seamless transition between small and large data. For pandas users, it will help to scale out the pandas code and make learning PySpark much easier. And for PySpark users, it will provide more productivity by its pandas-like functions. Let's review what pandas is. Pandas is the standard tool for data manipulation and analysis in Python. Pandas is deeply integrated into Python data science ecosystems, and it can deal with a lot of different situations. Python data scientists tend to start learning how to analyze data with pandas. Pandas works really well for small dataset in a single node, but unfortunately it doesn't work well with bigger dataset. Data scientists have to learn PySpark or other libraries if they want to handle bigger dataset. On the other hand, what is Apache Spark? Spark is the de facto standard unified analytics engine for large-scale data processing. It supports streaming, ETL, machine learning, and so on. It provides PySpark API for Python, as well as APIs for Scala, Java, R, and SQL. Koalas DataFrame follows the structure of pandas and provides pandas APIs. Also, it implements the concept of pandas index or identifier. On the other hand, PySpark DataFrame is more compliant with the relations or tables in relational databases, so the PySpark APIs are rather only essentials to perform relational operations. For example, Koalas provides series or index as well as DataFrame, and it can pick up some rows based on the index values or their origin index number. Even if Koalas objects have the same APIs as PySpark's, the behavior will be different since it follows pandas behavior. Koalas translates pandas APIs into a logical plan of Spark SQL, and the plan will be executed by Spark SQL engine. The execution will be done lazily so that Spark SQL's optimizer can come in. Then let's look into APIs for PySpark users to work with Koalas. The first APIs are to convert from and to PySpark DataFrame, as it's good for PySpark users to know how easily we can go back and forth between Koalas and PySpark DataFrame. You can convert PySpark DataFrame by just calling to Koalas function, like sparkdf.toKoalas, which is automatically added to PySpark DataFrame when running import command. The function takes index call parameter and it indicates which columns should be used as index. If you don't specify the parameter, the default index will be attached. I'll describe about the default index shortly. Here are the examples of toKoalas function. As you see, just calling toKoalas function converts PySpark DataFrame into Koalas DataFrame, and it looks like a pandas DataFrame. The left-hand side, index call parameter is not specified and an extra column appears as index. The right-hand side, on the other hand, the extra column doesn't appear and the column X is used as an index instead. The X column as index in the left example is the attached default index. Also, let's see how to convert Koalas DataFrame back to PySpark DataFrame. Koalas DataFrame has two Spark functions, and also it takes index call parameter. Without the parameter, the converted PySpark DataFrame doesn't include the index columns. If you specify the parameter, the string will be used as the column name. If there are multiple columns used as index, you have to specify the same length of string list. Here are the examples. The KDF has 3 columns, X, Y, Z, and an index. But the left example shows that the converted PySpark DataFrame doesn't include the index columns. The right example specifies the index call parameter and the column remains. Here we should consider about index and default index. As you saw, Koalas manages a group of columns as index, and they should behave the same as pandas. When you have pandas DataFrame and convert it to Koalas, Koalas automatically picks up from the pandas DataFrame. But other data sources like PySpark DataFrame don't always have an index. What if the index call parameter is not specified? Koalas will automatically attach a default index to the data frame. Koalas provides 3 types of default index. As each default index has pros and cons, we need to decide which index type we should use carefully. Actually, the default index is used in a different situation. For example, you set index without any remaining index columns. So please don't forget to consider about the default index anyway. The 3 index types are sequence, distributed sequence, and distributed. The sequence is the default value. This guarantees the index increments continuously, but it uses non-partition window function internally. It means all the data need to be collected into a single node. This is basically for testing purpose and should not be used with a large dataset. The second option is distributed sequence. Once the index is attached, the performance penalty is not as significant as sequence type. It computes the index in a distributed manner, but it needs an extra Spark job to generate the global sequence internally. This index type can be used for most cases, but there are still some performance penalty. The third option is distributed. It has almost no performance penalty and always creates different numbers, but the numbers have an indeterministic gap. It means this index type can never be used as indexes for operations on different data frames. Please also see the user guide for more detail. Secondly, we'll see I/O functions. There are a lot of functions to read and write data in pandas and in Koalas as well. The APIs in this list are equivalent to pandas functions. Koalas provides these functions, but these use Spark I/O under the hood. These APIs take index call parameter the same as to Koalas or to Spark. Also take keyword arguments for the case you want to specify more options for the underlying Spark DataFrame reader and writer. Koalas provides more I/O functions. The first pair is for reading and writing the existing tables in Spark SQL. The second pair can be used as almost the same as plain DataFrame reader and writer. These are only essential parameters. There are only essential parameters for ease of use and keyword arguments to specify other format-specific options. Last but not least, Koalas also can read and write Delta tables if you have Delta Lake installed. Delta Lake is an open source storage layer that brings reliability to data lakes. Please see Delta Lake documents for more detail. These APIs also take index call parameter and keyword arguments, the same as the previous ones. Lastly, before the demo, let's see Spark accessor. Spark accessor provides functions to leverage the existing PySpark APIs easily. These functions are to use Spark column or DataFrame within Koalas objects. Series Spark transform takes a function to modify the columns and returns Koalas series. The argument of the given function is actually Spark column instead of Koalas objects. So you can use Spark column APIs to modify the column. There are other similar functions, series Spark apply or DataFrame Spark apply. We'll see the examples in the demo later. The others must be more familiar to PySpark users. Check the underlying Spark data type or schema, explain the execution plan, cache the data frame, add hints, and so on. Spark accessor provides those APIs. Then let's see the demo. Please welcome Hejun.
Hi everyone, I'm Hejun from Databricks, and I'm gonna show you a simple demo for previous slide from Takuya. Then let me start. First, of course we should import the Koalas package. I'm using Koalas 1.3.0 for this demo. And then set the base path for reading and writing the data and set the default index type to distributed. Koalas has three types of default index as Takuya introduced in the previous slide. So let's start the demo with using Spark I/O. There are a lot of functions to read and write data in pandas and in Koalas as well. So we can easily create the data frame from CSV file using read CSV just like pandas. The result looks good, but I want to use employee ID as an index rather than attaching the default index here, because it could quite expensive. So to avoid attaching the default index, we should specify the index call parameter just like this. And now there is no default index, and employee ID is used as an index. And we can also create the multi-index by specifying the list of column names to the index call parameter. Then now we have a multi-index in our data frame. And not only pandas is IO functions, but Koalas also has Koalas specific IO functions. Read delta and to delta is one of them. Different from the other file sources, the read delta enables users to specify the version of the table to time travel. So let me quickly show you how to use it. First, set the path for delta file and write the delta file using toDelta. After writing, we can easily create data frame from delta file using read delta. It's exactly same thing what we did for CSV file. So we can see the create data frame from delta path. And next example, I want to increase the employee's salary by 20%. So first, I'm gonna just simply multiply the salary column by 1.2 and cast to int type to keep the type of salary column. In the result, we can see the increased salary. After that, I'm gonna write the updated delta file to the delta path. And read again the data from same path. Then, of course, we can see the latest data. We just updated the salary. But at this point, read delta allows users to read a specific version of data. For example, we can read the data of version 0 like this. Then we can see the original data which is not updated the salary. Let's go on to the next part, conversion from and to Spark DataFrame. For a PySpark user, it's good to know how easily you can go back and forth between a Koalas DataFrame and PySpark DataFrame. So first, let's see the how can we convert Koalas DataFrame to Spark DataFrame. So all we have to do is just simply use the toSpark on the Koalas DataFrame. The result looks good, but the index is lost because I didn't specify the index call parameter when I run toSpark. So there is no employee ID, so that's why this code will raise an analysis exception. Because we have no employee ID our Spark DataFrame. Again, we should specify the index call to preserve the existing index column. And now we can see the employee ID from created Spark DataFrame. Next, convert Spark DataFrame to Koalas DataFrame. When importing the Koalas package, it automatically attaches the toKoalas function to Spark DataFrame. So we can simply use this function to convert Spark DataFrame to Koalas DataFrame. And again, we can see the auto-generated default index here, which could be quite expensive. So to avoid attaching the default index, we should specify the index call like this. In the result, there is no default index, but employee ID is used as an index. Next part is Spark accessor. Koalas provides the Spark accessor for users to leverage the existing PySpark API more easily. So first, let's see the series Spark accessor. It is possible to apply the Spark function directly to the Koalas series with Spark accessor. So in this example, I want to remove the dash from phone number series using transform supported by Spark accessor. So we can use any Spark functions for Spark column in the Spark transform. So in the result, there is no dash in the phone number series anymore. But if the result has a different length of series, we should use Spark apply rather than Spark transform. So in this code, I just want to get a maximum salary from salary column using Spark accessor. And we can see the proper result, which has different lengths from the original series. And we also have a DataFrame Spark accessor. It is also possible to apply the Spark function directly to the Koalas DataFrame with Spark accessor. So in this code, I want to filter the only Gmail users from DataFrame using Spark accessor. So here we got a result, but there is auto-generated default index again. So we also can specify the index call parameter here to avoid attaching the default index. And now we can see the employee ID is used as an index in the result. Let's go on to the next part. Yes, so we also can check the underlying Spark data type or schema with Spark accessor. So we can check the schema by using schema or print schema function. First, let's see how schema function works. We can see the schema of columns in the result. So there is Gmail users and Gmail address and also their type. And next, let's see how print schema function works. And also we can see the schema of columns in the result. But we cannot see the employee ID column in the both printed schema. This is because I didn't specify the index call parameter when I run the functions. So if you want to see the index column in the printed schema, you can also use index call parameter for these functions. And next example is explain Spark plan. So when you want to know the current Spark plan, we can use explain function using Spark accessor, just like PySpark. So in the result, we can see the physical plan, which is generated by underlying Spark planner. And next, cache. The Spark accessor also provides cache-related functions. So we can simply use cache in the context manager like this. So in the result, we can see the storage level for current cached data frame. And you should know after the context manager, the cache will automatically be unpersisted. So, and if you want to use another storage level, you can use the persist function and specify the storage level you want to use. And now we can see the changed storage level in the result, or we just can cache the data frame outside of the context manager and unpersist later. So first, cache the data frame by using Spark accessor. And next, we can easily unpersist the cached data frame by using unpersist function supported by Spark accessor. And please don't forget to unpersist after using cache in this case. And the last part of this demo is hint. There are some join-like operations in Koalas, such as merge, join, and update. So of course, the actual join method depends on the underlying Spark planner under the hood, but we can still specify a hint by using the broadcast or hint function. So here we have two Koalas data frame, KDF1 and KDF2, and I want to merge them. But yeah, before I merge them, so before I actually run the code, I want to know the internal Spark plan. So I'm gonna use explain function again. Now we can see the physical plan in the result, and I want to give some hint for addressing the plan. So in this case, we can give the hint by using broadcast or hint function. So first example is broadcast. And now we can see the broadcast hash join in the physical plan, different from the previous Spark plan. And next example is basically same as above, but I use hint function supported by Spark accessor and give the parameter as broadcast. So as we can see, the result also same as above, but in particular, hint is more useful if the underlying Spark is 3.0 or above, because more hints are available in Spark 3.0. For example, broadcast, merge, and shuffle hash, shuffle, replicate, NR, and etc. are available in Spark 3.0. So I'm gonna use shuffle hash in this example. So we can see the shuffled hash join in the physical plan. Yeah, basically that's all from this demo. And thanks for your interest in Koalas, and thanks for watching this demo. Enjoy the summit, thanks.
Well, please get started soon. If you are a Databricks user, you can use Koalas without installation on Databricks runtime 7.1 and higher. Otherwise, you can install with PIP or Conda. If you don't have a Spark cluster yet, you can also install PySpark with PIP or Conda for your local computers. There are other useful resources you can take a look. If you have any suggestions, questions, or feature requests, please feel free to file an issue on the GitHub issue page or directly submit a PR. Your contributions are always welcome.